In this lesson, we shall focus on mathematics and we shall proceed to solve this particular polynomial question in front of us. Let f at x be equal to x to the fourth power minus 5x cubed plus 5x squared minus 5x plus 4. F at x equals x squared plus 1 times x squared minus ax plus b. We need to find a and b. We need to factorize f at x completely. Right, we need to factorize f at x completely. And we actually have exactly the following. Right, to actually find a and b, we begin as follows. But first things first, we take note of the fact that the fourth degree polynomial, which is obviously our quartic polynomial, has been factorized into a product of two quadratic polynomials. And so we want to actually find the numerical values of a and b, and we actually will proceed to find the numerical values of a and b, and we shall use the method we call the box method. We shall use the method we call the box method. And so using the box method, how do we find the numerical values of a and b? We begin as follows, right? So we're going to realize that in this particular case, we have the following. These two factors are both quadratic. And so in this particular case, using the box method, we shall perform the following construction of our box. And so performing the construction of our box, we shall have exactly this row here, this row there, this row there. We have then x to the fourth power, x to the fourth power. Right, so now x to the fourth power is exactly this one. And we divide, obviously, in other words, we'll divide this polynomial here, x to the fourth power, by the polynomial x squared plus 1. And so the x squared plus 1 can be written as x squared, 0x, and then 1. Right, and so we have exactly this here. And so in this particular case, if we divide x to the fourth power by x squared, we get exactly an x squared. And then if we have x squared by x squared, we get x to the fourth power. If we have 0x times x squared, we actually have 0x cubed. 1 times x squared gives us exactly x squared there. Okay, we continue with our analysis of this particular box. Right, so we actually, moreover, look at the x cubed first. And now the x cubed, now here the 0x cubed must be actually compared with the minus 5x cubed there. And we actually need to put here minus 5x cubed. Why? Because the sum of these 0x cubed minus 5x cubed is going to give us minus 5x cubed. Okay, and so we divide minus 5x cubed by x squared, we get minus 5x. We multiply these two, we get exactly minus 5x cubed. We have 0x times minus 5x, we get 0x squared. 1 times minus 5x, we get minus 5x, exactly this way. Now we look at the x squared that is there. And now if you add all these x squared and the 0x squared, they give us exactly x squared. So, but the sum must be of the x squareds must be 5x squared. So this one can only be 4x squared. So that now if you take 4x squared divided by x squared, it gives us exactly 4. X squared by 4 gives us exactly 4x squared. 0x by 4 gives us exactly 0x. 1 by 4 gives us exactly a 4 there. Okay, we have exactly this. Now we continue with our box and try to make sense of it. But obviously now we look at the further extension of this box. And so if you have minus 5x and the 0x, the sum is obviously minus 5x. And so what can we therefore put here? We can only put here exactly what? So that the sum remains exactly minus 5x. So you can put 0x. You can put 0x. We can put exactly 0x. If you add this, you can put exactly 0x. So that the sum is actually exactly minus 5x. And so obviously, because if you attempt to divide 0x by x squared, you can see that the degree here is 1 of the x, and the degree here is 2. So we do not obviously continue with the division, and this actually constitutes what we call the remainder part of the box. And so we have this exactly. Now, what then is the next thing to do here? Right, the next thing to do is to actually realize that what we have here is that we have exactly f at x, which is x squared plus 1, right? And we copy the quotient. The quotient is what sits exactly at the top, which is x squared minus 5x plus 4. And so now this is f at x, which is x squared plus 1. And so what are the factors? Okay, so now in particular, okay, let's start here first and foremost. Let us actually focus on this for now. And answer the question first. We need to find A and B. And so if we compare, right, in other words, by comparing coefficients, right, by comparing coefficients, it is clear that our A is exactly 5, and our B is precisely 4 there. And the question obviously was we actually had to find A and B, and therefore we can see that our A is exactly positive 5, and our B is plus 4. We have solved this problem in a step-by-step fashion. But of course, we have solved the first part where we're to find A and B next. Next, we need to actually proceed to do the following. We need to proceed to factorize f at x completely. And so to factorize f at x completely, we take note of what we have already. So we already have that f at x is x squared plus 1 this way, and we got exactly x squared minus 4x plus minus 5x plus 4. Right, we got exactly minus 5x plus 4. And so our f at x becomes exactly x squared plus 1. And the x squared minus 5x plus 4 would be the same as what? Okay, now obviously to factorize this, we multiply exactly these 2 here, and we multiply x squared with the 4, which is 4x squared, which is exactly 4x squared. And so if this is 4x squared, we look for the two factors, two linear factors whose sum is minus 5x, yet the product is obviously 4x squared, and we can actually be rest assured that we have minus 4x together with minus x, because the product is exactly 4x squared, yet the sum minus 4x minus x gives us minus 5. So you have exactly x squared minus 4x plus 4, which is x squared plus 1. And then now we come here and we need to actually do some factorization within the parentheses. So we factor out x with x minus 4, and then we have x minus 4. We factor out the x minus 4 from within these parentheses, and that will give us exactly x squared plus 1. And factoring out the x minus 4, we have x minus 4, and then x minus 1. X minus 1. And therefore, we have managed to factorize completely. And the actual factorized version is exactly this here. Right, this is the factorized version of f at x. Now, this is the factorization to pretty much the simplest factors possible. However, You can note, therefore, that f at x itself is exactly x squared plus 1. We've rewritten it as x minus 4x minus 1, which is the factors of x squared are x minus I, x plus I, x minus 4, and then x minus 1. Okay, obviously these factors here are the factors that are complex or imaginary. And so obviously it is possible, therefore, to factorize these particular two stages. And so when we're interested in real factors, right, when we're interested in real factors, we stop at this point. We stop at this point of factorization, but this involves complex factors. This involves complex factors. This involves complex factors. This involves complex factors. Right, and so we have proceeded so far to find to solve this particular problem here. And this particular problem we've solved here is a very important one. And we thank you for lending us your attention. Until next time, right, take good care and goodbye. Thank you so much.